Hello, this video is for Stat 310, Handout 10, Part C, and will include pages 19 through 24. Okay, let's go ahead and get started. This handout will again use the Lions Males Only dataset that is available in the Google folder for Handout 10. Okay, so Part C is going to cover making predictions and also obtaining what are called confidence intervals or prediction intervals for those predictions. Our simple linear regression model setup here, or structure, has the following form. This part of the equation is going to give me the mean, and then again the error term is going to be the variability. I can use my data to make predictions, so let's go to page 20. So to make a prediction for the expected proportion of nose black, I can just use the estimated regression model. I simply need to plug in a quantity for age. So for example here, if I want to make a prediction for a lion that is 5.25 years old, I would just need to plug that into this equation. That's shown on the graph here as well. It looks like that prediction will be a little bit over 40%, or a little bit above 0.4. The root mean square error quantity given by under my summary of fit output is going to be my standard deviation in that conditional distribution after conditioning on age. So this is going to be what my standard deviation is going to be in the proportion of nose black after conditioning. From Part B, we make an assumption that this data follows a normal distribution. If I have a mean quantity and a standard deviation quantity, and I assume normality, I can use the empirical rule to obtain an interval for this prediction. So that's what we'll do next. So here I have the naive 95% confidence interval for a prediction. And I'm talking about making a prediction for an individual lion. So again, if I have a mean, which I have estimated that to be 0.41, I have a standard deviation, which I get from my root mean square error. And I know from the empirical rule that if I use an interval multiplier of 2, I should get about 95% coverage. So if I take my mean, subtract 2 times my root mean square error, or my standard deviation, I'm going to end up with about 0.16. That's a lower endpoint for what I would expect my predictions to be. I do not expect my predictions or anticipate my predictions to go below that. Nor do I expect it to go above about 65%. So this naive confidence interval here, or prediction interval, is just trying to show me how much I can expect this prediction to vary over repeated sampling. Again, if I get a different set of lions, I'm going to end up with a different line. So certainly my prediction is not going to be exactly 0.41 again. And this naive prediction interval kind of gives me a range for what I can expect my prediction to be. There are actually 2 types of intervals that we can use. One is called the mean confidence interval, and the other is called an individual confidence interval. The individual confidence interval is more widely known as the prediction interval. But JUMP uses this terminology of mean confidence interval and individual confidence interval, and I actually prefer that terminology because it's more clear in what we're talking about. So the purpose of a mean confidence interval is if you have a group of lions that all have the same particular X value. So let's suppose that I have a bunch of lions that have an age of 5.25. If you're interested in the mean of that group, then you would want to use a mean confidence interval. An individual confidence interval, or a prediction interval as it's sometimes called, is used for an individual observation. So that would just be for a single lion. A lot of people will get these two confused. And in practice, most of the time, we are interested in an individual confidence interval. So let's talk about how to get these in JUMP. Once I have fit the model, from my drop-down menu, under the red drop-down menu here, I can say Save Columns, and I can ask for the predicted values, I can ask for the mean confidence interval, and the individual confidence interval. So let me go over and show you how to do that in JUMP. So here's my data. I'm going to fit a model. And from my red drop-down menu up here in the top, I'm going to say Save Columns, Predicted Values, Save Columns, Mean Confidence Interval, and Save Columns, Individual Confidence Intervals. And what that does is produce several additional columns in my spreadsheet or in my data table. So here's the predicted values that I saved. Here are the lower and upper 95% mean. And then over to the right even more, I have the lower and upper individual confidence intervals. Okay, so let's talk about those values. Go ahead and delete these out. And in particular, let's talk about a lion that is at age 5.25. So all I would need to do is find that lion whose age is 5.25. I can get the predicted value here, which was that 0.41. I rounded it, but it's 0.406 in JUMP. And then I get two quantities here, two intervals. I get the lower 95% mean, and I get the lower and upper 95% individual. So let's talk about the individual values first here. The 95% individual confidence interval goes from 0.155 up to 0.657. So the interpretation here is that we are 95% certain that a lion who is 5.25 years old would be predicted to have about 16% up to 66% of their nose being black. So again, this is just an interval for my prediction. The 95% naive interval that I obtained up above is pretty close to this individual confidence interval. So up above, I think I had 17 to 65 or so. Again, pretty close to what we're getting here. So that naive confidence interval was actually for an individual lion. Now let's talk about the mean intervals. So let's suppose here that I have a group of lions, each with an age of 5.25. The mean confidence interval is going to go from 0.36 up to 0.452. The interpretation here then, if we are 95% certain that a group of lions, each with an age of 5.25, will, on average, have 36% up to 45% of their nose being black. So it's a lot narrower. Notice that this interval is a lot narrower than an individual. It's always easier to make a prediction about a mean than it is about an individual observation. That causes some confusion because in practice, the 95% confidence interval is sometimes used in place of the 95% individual confidence interval. As I said before, the 95% individual confidence interval is sometimes called a prediction interval. Now that mean confidence interval is much narrower than the prediction interval. Now this oversight means that people are going to have a false sense of precision for their prediction if they use the mean interval instead of the individual interval. So again, here on page 23, if I just had a whole bunch of lions with that age, I'm going to get a variety of predictions. This would be the 95% mean confidence interval here. Finally, what if I want to make a prediction for a new lion, one that does not exist in my data set? So here I want to make a prediction for a lion that is 10.35 years old. what you're going to want to do is, instead of saving predicted values, mean confidence interval, and individual confidence interval, is to use the formula versions of these things. What that's going to do is actually save the formulas into your spreadsheet. And then I can add a new row, enter a new value for age, and these formulas will be updated automatically. So let me show you how to do that in Jump. So from my drop-down menu, from fitting my model, here I'm going to say Save Prediction Formula. And then I'm going to save the mean formula, mean confidence limit formula, and also the individual confidence limit formula. This produces all of the same columns that I had just earlier. But if you look inside of one of these, it actually has the formula that's being used to create that prediction, or here, being used to create the lower 95% confidence interval. I want to make a prediction for a new lion, so I'm going to say rows, add rows, and I want to add just one row at the end of my data set. Now I have one additional row at the bottom of my data set. I will enter the age for that particular lion that I want to make predictions for, which is going to be 10.35. And what's going to happen here is all of these columns are going to get filled in with this prediction. So here you can see that I get the lower and upper 95% mean confidence interval. It's going to be that value and that value when the lion is 10.35 years old. So that's what you can do to get predictions, confidence intervals, and prediction intervals for a particular observation, for a new observation, excuse me. Okay, that does it for handout number 10, part C for Stat 310. Thank you.